gentlemen, my name is Babongile Mapumulo. I will be representing my final design of the gas detecting and temperature regulation system. This video will follow the video that I had previously made on YouTube, okay, but this will be the final design. The basic operation of the system is that the system will detect any flammable gases present in the room. If there are any flammable gases that are detected above a certain threshold, the output will be that the buzzer will make a sound and the red LED will flash to inform the surrounding people of gases that are present that might lead to the cause of fire. If there are no gases present, the green LED will flash on to indicate that there are no gases and that the device is active. For the temperature regulation part, the system will monitor the room temperature. If the room temperature rises, the DHT11 component will detect that and it will perform the output of switching on a fan using a relay to perform the cooling of the system in order to bring the temperature back to normal. The implementation of the system could be in a household or in a working environment. It can provide security as well as comfort. For example, let's take a working spectrum. The workers can be monitored that the environment they're working in is safe as well as the temperature they're exposed to. This will be a picture of how the last presented video illustration looked like. As today I will only present the hardware system. This is the hardware system, how it was operating and functioning on the breadboard. For any system to function, it requires the building blocks, which represent the foundation of the operating system. So this is a block diagram just to give you a clear overview of how the system looks, what it entails, what are the inputs, what are the outputs, and how is the entire system controlled. As you can see, the system is controlled by an Arduino microcontroller. It has two sensors, in which one sensor is a double sensor, or you can say a dual sensor. It requires a power supply source as an input and a 9-volt battery, which will serve as an external source for the fan, as it will not be able to be controlled only by the Arduino. The results will be displayed on the LCD display. The relay will control the fan or will switch on the fan. And then you have a buzzer, a red LED, and a green LED. This is the flow chart of the entire system. This will illustrate the entire flow, what will take place after which command or which instruction. Okay, so when you're writing your code, you need to declare your variables, know your inputs and your outputs, set those pins accordingly. As you can see, I've declared my smoke sensor A0 pin to be an input, the DHT pin 7, the 9-volt battery is also serves as an input. You have your output relay input pin, which will control the fan. You got your green LED at pin 7, and then pin 8, and then you have your red LED pin 7, and then the buzzer at 10. The results will be displayed on the LCD. So the system will operate simultaneously, not that one portion of the system will wait for the other. No, it will happen simultaneously, although when I illustrate, I will not be able to illustrate it that way. So as you can see, the system, the MQ2 will read, take the pin. Is there any gases sensed? Well, if those gases are sensed and they're above a certain threshold, the buzzer will flicker on. The buzzer will make an alerting sound and the red LED will flicker on. Smoke is detected as a symbolization, and if not, the buzzer will be off, then the green LED will be on to symbolize that there is no fire or no smoke detected. On the other hand, the DHT pin, which is a temperature and humidity sensor pin, it will be red, and then the results displayed will be on the LCD. So if the temperatures are sensed in the room and they're above 30 degrees, the fan will be on as to counteract this disturbance, and then the temperature will be regulated back to normal. If not, then the relay will be off, and then that means that the temperature is stable. I made a box. I made it into a box just to close the entire system and make it look neat. So as you can see, the green LED is on. I've already uploaded the code. Green LED is on, symbolizing that the ambient surrounding is safe. There is no gases sensed, dangerous gases to be specific. The red LED is off and the buzzer is not making an alerting sound. So I have the gas lighter as I had last week, as I had on the previous video. This is to show that this MQ2 smoke sensor is very sensitive, and the gas lighter has LPG gas, which is a flammable gas, and the MQ2 will be able to pick up that and display the readings on the serial monitor. So if it goes above the threshold, the buzzer is supposed to make an alert to do the job. As you can see, the red LED is on and the buzzer is making that sound. I forgot to show you on the screen, but you will see the results that it actually picked up and shooted up. That threshold is way above 300, hence the alerting sound was made and the red LED flickered on. So I'm going to show you the temperature sensing part of the system. Okay, this is a temperature sensing part. As you can see that the other side has the fan and the DHT11 as well as the LCD display displaying the current temperature in the room and the humidity. As I've already uploaded the code, you can see the results. So I have boiling water. Well, I had boiled it. I'm sure there's still steam released. So I want you to see that the the DHT, I'm saying the LM35 because I had used it as well. It's also a temperature sensor. The DHT11 is the temperature and humidity sensor. So that by putting the water against this temperature sensing part, it will read on the the display on the LCD what is being read, and if that it happens that the temperature is above 30 degrees, then the fan will operate, or the fan will just operate so as to cool the ambient temperature as well as the humidity. Just gonna put it close enough. I want you to witness the changes. Maybe firstly the changes will be witnessed in the humidity because that is the air sensing part. I'm blowing it in there so that you can see changes in the humidity. Not so much for the temperature because I had boiled the water so long. Can you see that the temperature is 32 degrees, 33, and the fan is operating, so it will not stop until it goes back to 30 degrees because that was my threshold. That was the room temperature I had set. So this is our lovely system. Thank you. It's an efficient and quick system. It's just that this is a prototype, so I'm just displaying how the actual system will be in operation. Thank you so much for watching the video. This is the end.